Okay, let's talk about something that sounds like it's straight out of a science fiction movie. Quantum computing. I know, the word quantum can sound a little intimidating. It brings up images of crazy equations on a chalkboard and scientists with wild hair. But stick with me here because at its heart, the idea is incredibly cool and surprisingly understandable. Quantum computing isn't just about making faster computers to stream your favorite shows without buffering. It's a completely new way of thinking about computation itself. It's about building machines that work in a way that's much closer to how the universe actually operates on a microscopic level, using the weird and wonderful rules of quantum mechanics. Before we dive headfirst into the quantum realm, let's take a moment to appreciate the computers we use every single day. At their core, they think in a language of just two words, on and off. That's it. Everything they do, from displaying a complex video game to sending an email, is broken down into a massive sequence of these two states. We've gotten really good at making these light switches smaller and smaller, packing more and more of them onto tiny silicon chips. This relentless miniaturization is why your phone today is more powerful than the room-sized supercomputers of the 1970s. But we are starting to hit a physical limit. We're making these switches so tiny that they are approaching the size of individual atoms, and that's where things get weird. So if classical computers have bits, what do quantum computers have? They have something called a qubit, which stands for quantum bit. While the coin is spinning in the air, it's not heads and it's not tails. It's in a state of both possibilities at the same time. A qubit can be 70% a 1 and 30% a 0, or 50% of each, or any other combination you can think of. It's only when we decide to measure the qubit, which is like catching the spinning coin, that it collapses into a definite state, either a 0 or a 1. With just 300 qubits, a quantum computer could represent more possible values than there are atoms in the entire known universe. Imagine you're trying to find your way through a giant maze. A classical computer using bits would have to try each path one by one. It would go down one path, hit a dead end, turn around, go back to the start, and then try the next path. Now imagine a quantum computer using qubits in superposition. Instead of trying one path, it's like it can send a wave of possibilities down every single path in the maze all at once. The wrong answers cancel each other out, while the right answer gets amplified, a process called quantum interference. This concept was famously illustrated by the thought experiment of Schrödinger's cat, which is both alive and dead until the box is opened. If superposition is the first superpower of qubits, then entanglement is the second. And honestly, it's arguably even weirder. Albert Einstein famously called it spooky action at a distance. When qubits become entangled, their fates are linked in a profound and inseparable way. No matter how far apart you separate them, whether they're in the same lab or on opposite sides of the galaxy, they remain connected. Let's go back to our coin analogy for a moment. Imagine you have two special entangled coins. You give one to your friend and keep one for yourself. Your friend travels to the other side of the planet. Now, you both agree to flip your coins and catch them at the exact same time. The instant you look at your coin and see that it landed on heads, you know with 100% certainty that your friend's coin landed on tails. So, we have these amazing qubits that can be in many states at once thanks to superposition and can be spookily linked together through entanglement. But what does that actually let us do? This is the point where a quantum computer can solve a specific, well-defined problem that no classical computer on Earth could practically solve in a reasonable amount of time. Imagine being able to design a brand new molecule that makes a fertilizer far more efficient, or designing a new drug that perfectly binds to a virus to disable it. This isn't just theory anymore. As we sit here in 2025, the race to build a useful large-scale quantum computer is well and truly on. In 2019, Google claimed it had achieved quantum supremacy with its Sycamore processor. They designed a specific problem that their quantum computer solved in about 200 seconds. The impacts could be profound, starting with our health. The ability to simulate molecules could lead to a new era of personalized medicine. Instead of a one-size-fits-all drug, doctors could design a medication specifically tailored to your unique genetic makeup and the specific strain of a disease you have. Then there's the environment. Quantum computers could help us tackle climate change in several ways. They could help design new, highly efficient solar cells that capture more energy from the sun. They could simulate chemical processes to develop better batteries for storing that energy, making electric vehicles and renewable power grids more viable. Of course, there's a double-edged sword, especially when it comes to security. A powerful quantum computer could break much of the encryption we rely on today. But the good news is that quantum physics also offers a solution: quantum cryptography. Technologies like quantum key distribution use the principles of quantum mechanics to create theoretically unhackable communication channels. I get it. A lot of this sounds like it's decades away, something for future generations to worry about. But the foundational work is happening right now, and the pace of change is accelerating. This technology will create entirely new industries and jobs that don't exist today, from quantum software engineers to quantum ethics consultants. Furthermore, the development of quantum computing raises important ethical and societal questions that we all need to be part of discussing. An informed public is essential for making wise decisions and steering this technology in a direction that benefits all of humanity. The journey into the quantum realm is one of the most exciting scientific adventures of our time. It's a story about human ingenuity, our relentless quest to understand the universe, and our drive to use that knowledge to solve our biggest problems. It's not magic, it's just physics we're finally learning to use. And understanding it, even just a little, gives you a front row seat to the next great technological revolution.